Sarah and I decided to research the Large Hadron Collider for our final project. It is currently the largest, most powerful particle accelerator in the world, located beneath the France-Switzerland border near Geneva. It is 17 miles in circumference and lies 574 feet underground. The word hadron refers to any particle made of quarks, antiquarks, and gluons. This includes mesons and baryons, the most prominent examples of which are protons and neutrons. The main difference between mesons and baryons is mass. Baryons have a mass greater than that of a proton, while mesons are in between the mass of an electron and a proton. Basically, hadron is a fancy way of saying particle. The term collider refers to a special form of a particle accelerator which accelerates particles to a very high kinetic energy and then uses opposing beams to allow the particles to collide. This process is able to occur through the use of electromagnets and electric fields. The electromagnets control the direction of the particles, steering and focusing them through a vacuum. Electric fields provide the acceleration by switching from positive to negative. This process creates radio waves that accelerate the particles in groups. These collisions have been able to provide scientific backing for huge theories such as the Higgs boson particle and antimatter. A brief overview of the collider's history is as follows. On March 21, 1984, CERN, the European Organization for Nuclear Research, and the European Committee for Future Accelerators, ECFA, held a workshop in Lausanne, Switzerland, and at CERN from the 21st to the 27th. The event, Large Hadron Collider in the LEP Tunnel, marks the first official recognition of the concept of the LHC. During the event, attendees considered topics such as what types of particles to collide and the challenges inherent to high-energy collisions. On February 8, 1988, the excavation of the tunnel for the Large Electron-Positron Collider, Europe's largest civil engineering project prior to the Channel Tunnel, is completed. The two ends of the 27-kilometer ring came together with just 1 centimeter of error. On the 21st of October, 1993, the U.S. government canceled plans for the superconducting supercollider project supported by Ronald Reagan, which was the sole competitor to the LHC for a high-energy hadron collider. The SSC was supposed to have an 87-kilometer circumference and was designed to be much more powerful than CERN's LHC. On the 16th of December 1994, the CERN Council approved construction of the LHC. To solve a perceived budget issue, they decided to build the collider in 2 stages instead of just 1. At 10:28 a.m. on the 10th of September 2008, a beam of protons successfully steered around the 27-kilometer Large Hadron Collider for the first time. Inside the control room, physicists and engineers cautiously shot the beam down part of the tunnel, stopping it before it went all the way around. 1 hour after starting up, on the first attempt to send the beam circling all the way around the tunnel, it completed the trip successfully, bringing, as National Geographic reports, overwhelming applause. After a brief pause due to a helium leak in the system during which no one was harmed, the collider ended its first full period of operation on December 16, 2010. Collisions at increasing speeds continually set world records for CERN. On the 8th of October 2013, CERN congratulated François Englert and Peter W. Higgs on the award of the Nobel Prize in Physics for the theoretical discovery of a mechanism that contributes to our understanding of the origin of mass of subatomic particles and which recently was confirmed through the discovery of the predicted fundamental particle by the ATLAS and CMS experiments at CERN's Large Hadron Collider, the Higgs boson particle. This brings us to the 3rd of June 2015. After an almost 2-year shutdown and several months recommissioning, the LHC is now providing collisions to all of its experiments at the unprecedented energy of 13 tera-electron volts, almost double the collision energy of its first run. This marks the start of Season 2 at the LHC, opening the way to new discoveries. It will now run for the next 3 years. Many people question the necessity of such large, expensive projects like the Large Hadron Collider. So I found some defenses by scientists to help explain the everyday use of tools that research grand theories like this one. When Einstein developed his theory of general relativity, he just wanted to explain the way gravity worked. Now, your GPS locator in your smartphone uses the exact equations to remain accurate. Most particle accelerators are actually found in hospitals, in MRI machines helping with diagnostic medicine. The technology found in particle accelerators is already used for certain types of cancer surgery and research. The web was developed at CERN to help scientists transmit important pieces of information to each other and aid in data analysis.